So, hello, good morning, everybody. Hope you're here and you're still ready to take up some information, because this was, when I prepared the talk, it was a 45 minutes talk, and then the organizers came along and said, well, you've got 30 minutes. And I said, oh, well. And so I will need to cut a few corners, and probably I will talk at double speed. So if you're looking there, watching that on YouTube, don't try to speed it up, it won't work. you won't get a word anymore. So, okay, let's talk about resilience. And as you already mentioned, we will talk a little bit about what it is, because many people talk about it. Most people talk about different things. So we will clarify that, and we will clarify how you get there, so going through several stages. And then we will, at last, we will briefly discuss, do we always have to go the full 9 yards, or is it okay sometimes not take the full road? So, my name is Uwe Friedrichsen. I work for a company located in Germany. If you live in Germany, you probably might have heard it. If you're not living in Germany, you probably won't have heard it at all. So, okay. You can find me on the internet via Uwe Fried, and especially I will upload the unabridged slide deck. So I will show an abridged version here in the presentation to my speaker deck account, where you can download it, where all the details that I have to leave out right now will be included. And I run a blog at uwefried.com, where I will later this year, I will also publish a written version of this presentation. So you can read it up there then too, if you like to. But now let's talk about resilience. If I go to companies, they quite often say, yeah, we're talking about resilience and we are resilient and so on. And I first say, well, let's make sure if we're on the same page. Because quite often I figure out, if you talk about resilience and I talk about resilience, we talk about different things. So what is resilience? And I went through about 2 or 3 dozen definitions from several fields, also not only IT, but also psychology, biology, systems engineering, cybersecurity, and. And I tried to find a bottom line about what is resilience. And the bottom line that I've figured out is, resilience is the ability to successfully cope with adverse, so negative events and situations in a way, so successfully cope, that's the important part, that we're able to handle expected adverse situations. So that's not resilience, that's just robustness. But still, we need to have that, because everything else does not make any sense. So if we are not able to handle the things we expect, well, we are out of luck, basically. Then it comes to resilience. We're also able to deal successfully with surprises, things we didn't expect. That's a big difference, as we will see soon. And the last thing is, that's also belonging to resilience, not always included, is the ability to learn from these situations. So to be better off after the situation than you were before. It's called anti-fragility. And if you have read Nicholas Taleb's book about anti-fragility, where he says, yeah, well, resilience is something different than anti-fragility, well, he used a little bit tweaked, crippled definition of resilience, which left out the last part. But it definitely belongs to resilience. And then some people, including me, also talk a lot about resilient software design. This is what we can do at the technical level in our systems to improve or to support the stuff which I described above. But just keep in mind, you can never make a system, a technical system, resilient, at least not right now. You can make it robust at best, but robust is better than nothing. So, but we will talk about that a little bit more in the future. So, just about the failure modes, then, if you go for that definition, it's not only hardware failures or some kind of latency we're dealing with, it's also bugs in our infrastructure, so firmware bug in our router or switch or something like that. Cyber attacks, software bugs, very often forgotten in this situation. I mean, redundancy is great, unless your system crashes, you fail over the next one, it crashes due to the same bug, it crashes due to the same bug, and all your instances are down. So, well, so much about resilience if you're not able to fix bugs in a very fast way. And so, or something very unexpected, I had that one. So my data center just went down because I was responsible for running the data center, and it just went down because the triple redundant cooling, all 3 units failed at once. You never plan for that, to be honest. Well, or also in the business domain, and. There's a lot of things that's going on. And then, usually, my peers often say, well, I think we're talking about different things. But still, that resilience thing is interesting. So how can we become resilient? And I say, well, for starters, it's not a simple plan or something like that. It's not an easy road that you just have to wander or drive by car or anything like that. It's more like a mountain climb. So it's a bit tedious, it's a bit risky, there are some obstacles in the way and so on. And the higher you go up, the bigger the obstacles become. Still, it's not Mount Everest, it's Mount Resilience. So it's climbable. That's the good part of the message. So let's try to climb up. So what I have laid out now is some kind of prototypical evolution of a company from nothing to resilience. It's more like a reasoning framework that you can use to figure out where you are and what you used to do to come to the next stage. And finally, we will discuss if you really have to go up all the stages. Okay, so this is a sketch of Mount Resilience. As you see, painting is not one of my strong traits, but still, it's good enough for a map. So just X marks the spot. So we see it as a valley, quite nice, with a lake and something like that, and then a path that's going up, some plateaus in between. Well, let's start down there in the valley. I call the valley of feature completeness. So that's where many companies are still right now that I see. Valley of feature completeness is, so dev is responsible for the features, and ops is responsible for availability. Because if we talk about resilience, we also talk a lot about availability. Availability is the fraction of the time where your system responds according to its specifications, so where it creates value. And we try to maximize that part, basically. And whenever something odd happens, we want to make sure that it doesn't knock over our system or that our system comes back up very fast again and so on. So to maximize our availability. By the way, if there's anybody working in security and safety-related domains, their reliability becomes a more important issue, but we're not going deeper into that one. We're just touching it a little bit, why that's important there. But usually we're talking about availability. So ops responsible availability. So the dev budget usually then simply goes into features. Features. We don't have time for anything else. It's typically the typical answer from the product manager or the product owner, whoever it is. And all the non-functional requirements besides maintainability are usually outsourced to ops, including availability. So yeah, that's ops responsibility. Okay, again, I see that if you attend a lot of conference talk, you might think there's that is a thing of the past. But I see that still quite often in companies, this separation of concerns. So, and in the dev department, the core driver is then, let's maximize feature throughput. So, and the leading question then is, okay, how many features can I implement in a specific unit of time? Can I become faster? Are the features implemented correctly? And so what you see in terms of availability is everything that ops can handle. So they have this kind of infrastructure which is redundant in some way, or the middleware, so load balancers with failover, some kind of cluster solutions, high availability hardware, blah, 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 blah. And because they do not trust dev by any means, because they're just thinking about feature completeness and not about production readiness, they have strict handover rules, they have long test phases, and. So we're not going here, for sake of time, into the trade-offs and all that stuff in detail. The question is just, what gets us moving? What's the blind spot here? And the blind spot is basically, yeah, well, everything besides features, which is a lot. Especially that they completely miss the reality of today's system landscapes. Because this approach was okay in the 80s and 90s, and maybe in the first half of the 2000s, when systems were monolithic, quite isolated, and communicating via batch interfaces. Then the biggest concerns you had about availability was that either your hardware or your infrastructure failed, ops responsibility, or you have a bug in your system. Well, that's then responsibility of dev, and that's it. So, but these days, systems are different. They're distributed. We switched from batch communication to online interfaces. We always ask the other system for the information right in time. And now we have remote communication. Remote communication means that we are in distributed systems. So our task has fundamentally changed. Distributed systems means that we try to implement some kind of deterministic behavior on top of a non-deterministic foundation. If you attended a talk from Jim Weber yesterday, he talked about that distributed systems always fail. And yeah, it's because they're non-deterministic, and it goes down to the physics. You can't avoid it in some way. And all this non-determinism bubbles up to the application level. So you can't simply go and say, well, we catch that all at the infrastructure middleware level. And the application level, they don't need to know about that. I mean, 1994, Jim Waldo and some of the colleagues from Sun wrote a nice paper, a very good paper about a note on distributed systems where I said, you cannot hide distribution behind interfaces that simulate local communication like RPC or anything like that. It does not work. So it's known for more than 30 years meanwhile, but anyway. And it bubbles up to the application level, which means the realization starts to kick in. That starts the journey, basically. The first realization you have to have is, well, we can't just leave it to ops. Also here at dev, we have to take care about availability in some way. And this brings us to the first level. By the way, it's not that just someone has to have this realization. As a company, we have to agree about that. At least as IT and business departments, we have to agree about that. And this brings us up to this plateau of stability. And the plateau of stability is still saying, well, we want to maximize our availability, therefore we have to avoid failures. That's the first level that you usually see in companies. I still see a lot of companies being there. Avoiding failures gives us then typically the questions, how do I avoid crashes and how do I avoid overload situations? Most of the time they're thinking about crashes and overload situations, nothing else. And so how can we avoid them? How can we detect them? How can we fail over? And all these things. These are the leading questions, which then at the application level leads to some things like these timeout measurement, so timeout control, circuit breakers, which then fail over to other redundant nodes that you have. If you're in a cloud environment, you use the application load balancers, auto-scaling features, or you use the rate limiting of your API gateway, or maybe if there's no API gateway, you use then the back pressure if it's built into your framework that you're using, like Akka or something like that. And typically, the developers then resort to some features that are provided by the infrastructure. So redundancy, Kubernetes, timeout circuit breakers, your service mesh, auto-scaling, the cloud infrastructure, rate limiting, the API gateway, and so on and so on. You're not building into the application, which is okay, basically. It's quite straightforward. It's a focus on technical measures. What's also important here is you never talk to your business owner in some way. We will see why that becomes important on the next level. So it's technical measures. And it's okay. Not bad. It's better than the other one, definitely. Still, there's a blind spot. And the blind spot is this 100% available trap that we quite often see. The 100% available trap is, here's a little example I have from real life, from a real project I was in. There was a team that was responsible for some kind of subdomain inside a bigger business system. And they designed it in a service-based approach that they said, okay, here is a central service, and there are a lot of servers arranged around them which interact with the other systems and the user front ends. And I asked them, by the way, what do you do if this service in the middle goes down? And they looked at me quite puzzled and said, well, nothing. Because this one in the middle is so important, simply must not go down. We have to make it highly available. So we didn't implement any extra measures. And the other developer says, well, yeah, also at the functional level, we can't do anything useful anywhere if the service is down, so it has to be up. So the problem is, if you think about fault tolerance always says, split up your system in parts and isolate them against failures each other so that you limit your failure blast radius. The problem is, if there was a failure in the middle, it took the whole system down. The whole system was dead. So they have maximized their blast radius accidentally. And not because they were dumb. They fell into the 100% available trap. So like also, they were thinking, they can make the service in the middle 100% available. but they can't. We see it quite often, not only there, but also with infrastructure components. Here, my underlying hardware and infrastructure will never fail, or my middleware components. As soon as I have delivered the message to the message bus, I'm safe, and it will never fail. Nothing will ever fail if I delivered it to. We see that quite often. I'm quite often in the Java community, and they're completely convinced. As soon as they deliver the message to the message bus, they're safe. They're often safe. And also, of course, all the other parts of the system are never down, all the other systems. So it's basically the successor of this ops-responsible availability mindset. So availability of these other parts is not my responsibility, so I assume this is available 100% of the time. I only have to make sure that my part is also available 100% of the time, and everything's available 100% of the time. The problem is, there is no 100%. Everything fails once in a while. Everything. Or as how Michael Nygaard phrased it, continuous partial failure is a normal state of affairs today. Or even better, so thinking about distributed systems, what Werner Vogel, CTO of Amazon, said, everything fails all the time. Right? That's systems reality in distributed systems. So they're a cool thing, but we have to accept failure. So this leads to the second realization, second insight, which is failures are inevitable. You can't avoid failures, period. And now we have to go back to our formula for availability. I mean, what I said in the beginning, we try to maximize availability. And the people from the stability thinking, they try to maximize mean time to failure. So the time from start of normal operations until we see a failure of some kind. We try to make it bigger, 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 bigger. Because if you look at the formula, it's down there, there's mean time to failure plus mean time to recovery, which means this one is bigger than the part up there. And so making this as big as possible, so bringing that as closer to 1 as you can do, or 100% if you like, percent better, is trying to make mean time to failure very big compared to mean time to recovery. And so stability folks said, we just have to maximize mean time to failure really, 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 really big, and then mean time to recovery doesn't matter. So robustness, people say, okay, there will be failures. So we try to make mean time to failure bigger, but there's limits to it, what we can achieve. And if we want to increase availability further, we have to reduce the time for recovery. So from detection of failure until we're back to normal operations. So we have to take both things into account. That's robustness thinking. And there's a second realization, quite straightforward, which says, well, there's not only crash failures and overload situations. There's a lot of failures that can happen. So we have all the kind of failures that distributed systems have in their luggage. We have software bugs, we have firmware bugs, we have security vulnerabilities. We have tons of different kinds of failures. We have to think about all of them, and not just about crash failures and overload situations. That's not enough. These are simple, by the way. The other ones are hard. So, and this brings us up to the next plateau, a little bit harder to get there. And as I said, we think about maximizing availability there, which is then kind of different set of questions like, hey, what could go wrong? What can I do to respond to that very quickly? Like, for instance, also fixing bugs, or if I get some information I can't process properly, and all these other things that can happen. And think about measures to deal with that in a reasonable and sensible way. And we see different kind of measures then, response patterns there. What we typically do is we're not only going for failover, we're going for fallback. Fallback is my plan B if my plan A fails. And that fallback is at the business level. So I go to my business owner and ask them, okay, if this technical system over there fails, what is a sensible response at the business domain level? So can we offer something at a reduced business service level which still makes sense for the users if we can't reach this other system over there? It's a very different kind of discussion than just trying to configure my infrastructure and middleware components in some way. So we have to have this discussion now. We have to implement complete parameter checking. Everybody says, well, don't we do that anyway? Okay, if everybody would do complete parameter checking, 95% of all CVEs would be gone instantaneously. So no, we're not doing it. So, but this minimize startup time. We also try to automate our deployments because software bugs, little source, and we have to, yes, bring our monitoring to the next level. We don't need observability here yet, but we need a good monitoring to detect failures early. Yeah. And as I said, it goes now not only in IT, we also have to talk to the business owners, so they're involved here some way. And we also touch the process a little bit. So it's a bit more work, it's harder, but still doable. Again, it takes this realization. So, and we can achieve quite good availability here and all sorts of stuff. So what's the blind spot here? It's the limits of perception. What's the limits of perception? Yeah, well, as long as failures come along that we expect, everything's fine. But the problem starts when something comes along that we do not expect. Because then we have a surprise. Problem is, surprises are not, they're not avoidable in some way. So surprises happen. Failures happen and surprises happen. And sometimes it's not okay if we can't respond properly to surprise. For instance, if we're in a safety critical domain. Safety critical means people can die if our system fails. And we won't run into the situation that our people die because a surprise took our system down. We stand there and just say, whoa, I didn't see that one coming. That's a bad situation. I mean, it's a cool one-liner if you're the villain in an action movie, but it's not good in such a situation. So you want to be prepared for that one. And also, the other thing is that when you think about what can I build into the system, you easily figure out, not much. Because surprises, you can't build how to handle surprises, so things you do not know that they might happen at any time into your system. Because for writing something into your system, to write some line of code, you have to know the situation in some way. So you realize, okay, system, they are good corresponding to known kinds of failure situations. That's robustness. For going to the next level to resilience, I have to incorporate the whole socio-technical system, the whole system involved, development, operations, how the failure is handling, business department, up to the first level support and everyone else. So that's what resilience is about. And we have to think about all these levels. So if you're working in an architect role, welcome to the socio-technical systems here. Which brings us up here. And here, basically our driver is, yeah, well, it's the next layer. We expect the unexpected. So the questions, again, change quite a lot. So like, is there a way to figure out in some way easier or to increase the probability to detect some unexpected things? And what kind of resources does my organization need to really respond to that? Yesterday with Alan, we heard about Slack. Yeah, Slack now comes into play in some way. So they need some capacity to respond to it, to absorb these surprises in some way, and also to respond to that. We might need some technical resources. We might need to all reorganize. We might even change the boundaries of our IT organization, how we collaborate with other ones. And we have, and this is the hardest part, to balance resilience and efficiency. Because most companies are efficiency obsessed. It's a thing from the past, basically. It's not our problem these days anymore, efficiency, but all kind of new problems they try to address with more efficiency. Would be a talk in itself, or maybe several talks, and have to explain that all with industrial markets and production methods and so on, and maximization of profits and so on, and changing market situations, blah, 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 yada, yada, yada. But they're still obsessed with efficiency. But efficiency, beyond some low-hanging fruits, means reducing variance. So reduce the variance of the expected settings of your environment, of the expected states of your environment. Further, 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 further. Surprises means you're outside. Oops. And the problem is, if you have a highly optimized system, for instance, supply chains are a highly optimized system, a totally over-optimized system. And then there comes the ever-given and makes this in the Suez Canal. A surprise. Nobody thought about it. And it took 3 days. And it took them 6 months to get back in line. That's how a highly optimized system responds to surprises. And we can't afford that here if we're in a safety-critical context. So we have to reduce our efficiency a bit to become resilient. That's the hardest discussion we will probably have here. And the measures typically are things like self-organized teams and fire drills, chaos engineering. We have to introduce Slack into the system. We have to really have observability now. So being able to ask questions about how are we doing, how did the system, so what's going on in the system in the past and right now and in the future. So in some way, what's to be expected there and all these things. And we have to think about the whole socio-technical system. You see, the game changes a lot here from just building a few circuit breakers into, wow, rethinking our whole organization. And it's, yeah. So as you see here, so our impact radios go up to the whole organization. Technology changing is easy. Business domain owners to convince business domain, it's a bit harder. Changing process is even harder, and changing the organization is the hardest, basically. And for climbing to the peak, just briefly, what we can now is we know how to respond to surprises. We can either withstand them, saying, well, we have got enough capacity that you do not knock me over, or quick recover. So it knocks me over, but I get up very quickly. Okay, but we still do not learn. So we stand still. And it's okay if we can stand up very quickly, but if we have to stand up over and over and over and over again, it doesn't make sense. So maybe we should figure out how to learn from that and position ourselves a little bit different, our organization, our IT systems, or how we respond to the market or anything like that. Saying, okay, that surprises don't happen that often and bad situations. And that's basically the last realization, leverage the learnings to figure out how we can slowly adapt our positioning, or maybe in some situations, how we even can leapfrog in some way and reinvent ourselves. Quite a lot of companies did that, for instance, at the beginning of the COVID phase. So figured out, oh, we can't survive if we do things, the same thing we ever always did. We have basically to reinvent ourselves in some way. That's leapfrogging. So is this, we embrace surprises, adverse situations as an opportunity to become stronger, basically, to learn and become stronger. I was sure I didn't have that one in here. So I already talked about that, and so we made it to the peak. I left out a few details for that one. We're up here, we're resilient, and we even learn, we become stronger and stronger, whatever kind of surprises hits us. The last questions we want to go through then is, do we always need to go up there? I mean, that's a long way, and it's quite rocky, the last part of it. My take on that is, okay, down here in the valley of feature completeness, it's nice, but it doesn't make a lot of sense usually in normal business settings here. Or the IT landscapes are in a different way, so don't do that if you're able to. Stability, so avoiding failures, it can be okay if you do not have too high availability demands, if planned downtimes are okay, and so on. Then you can get away with that. And please make sure that your systems are not distributed internally, so no microservices. Not good for microservices. Monolithic systems communicating online with each other, then it's still okay, most of the time. Robustness you need if you want to go for microservices, so also thinking about minimizing meantime recovery. And you can achieve very high availability with that. So very often, it's good enough to go for that. If you're in a safety-critical domain, or if you really need very high availability under very uncertain business or technical in very uncertain business or technical environment, you need more. You really need resilience. And the last one is more, would be a different talk again in itself, is if you really want to play a successful game, an endless game, a successful endless game in a quickly changing, increasingly uncertain world. Because business and IT have become inseparable. One of the consequences of digital transformation is massively misused word, but there's a meaning behind that, but that's out of scope here. And so business IT are the same thing. You can't change business without touching IT, and everything business does touches IT and vice versa. So it's the same thing, basically. So if I think about business, I also think about IT. If I think about IT, I think about business. Can't separate that. And if I want to be successful in a VUCA world, we probably need that. But that's a different game. Probably not the game we have to discuss. So with all that, I hope I gave you a few ideas about what resilience is. I gave you a little bit of reasoning framework. Where are we? Where do we need to go? What are the leading questions for that? What do I have to take care about that? I wasn't able to fill in all the details. There are a lot of nuances in here and so on. But, well, ask me later, ask me at lunch, ask me whenever you like to, or read the blog post later this year. For now, the only question I have left is then, how far will you climb up Mount Resilience? That's what I had for you. I'm ready for questions. Thank you.
Thank you very much, Uwe. We have a